Now let's look at what is occurring within the tubular system itself. Now, we've talked about the different sections of the tubules: proximal convoluted, distal convoluted, and in between you have the nephron loop. Okay, and I previously mentioned that substances within the tubular fluid can be broken down into three categories: those substances that are completely reabsorbed, substances that are partially reabsorbed or otherwise regulated as to how much is reabsorbed, and that's going to be a big category, and then other substances that are excreted as waste products. Okay, so let's break those down, first looking at those substances that are completely reabsorbed, and I will point out as we go through this what sections of your tubular system, those three categories that we had, completely reabsorbed, regulated, and excreted, what part of the tubular system that is occurring in. Okay, so let's look at substances that are completely reabsorbed. So let's do this. Okay. The substances that are completely reabsorbed, those are the substances that are important for the body. Okay? We don't want to get rid of them because they have value. Now, what those substances are, we're going to look at something in more detail here. That's going to be glucose. That's going to be a primary one that we're going to look at. Other ones would be proteins. Okay, these would be smaller proteins. Larger proteins are still going to stay within the glomerular capillaries unless you've got some other issues going on with this one. But you don't want proteins in the tubular fluid. These are going to be smaller ones that we're going to be considering on what happens with those. We're looking at amino acids. Those are pretty darn small, so those are going to come across. Those are your basic ones that we're going to look at right here. Okay, proteins and amino acids, those are kind of going to work together, what we're going to talk about. But let's first look at what is occurring with glucose on this one, because this is a little bit more detailed what we're going to be dealing with. So let's go across here and let's look at this picture on this one. Okay, so on the bottom section here, this is your tubular fluid, and you've got your capillary up here, okay, just to orient you. And this middle section, that is your, in this case, this is going to be simple cuboidal epithelium lining the proximal convoluted tubule. Now, just about all of nutrients are going to be reabsorbed in the proximal convoluted tubule. So nutrients almost completely boy, I spelled that one wrong. Almost completely in PCT. Okay? I'm not going to spell that one. Okay, so that's what we're looking at. So nutrients, this is going to be in the proximal convoluted tubule. Okay? A couple things you can see within the proximal convoluted tubule. Let me just point it out. We've got these, this is the luminal membrane, and we've got like these, almost the villi here, that increases the surface area. Now, remember, if we increase the surface area, that allows for more movement across that membrane. So we want to increase the surface area here to allow for more of these nutrients to come across. Now, if we look at glucose specifically, how is this happening? Well, movement of nutrients from tubular fluid across the proximal convoluted tubular, or the simple cuboidal epithelial tissue, and into the blood. on the luminal edge of the tissue and on the basolateral edge, we're going to have transport proteins, okay? We're going to have something that has to be there in order for in this case, glucose to move across. It doesn't diffuse through the membrane itself. It has to have a carrier or a transport protein or something along that line. And what we have is we've got a certain quantity of glucose within that tubular fluid. So we've got a certain glucose, and I guess it's the purple ones here. No, that's the sodium. So the green ones are going to be representing glucose in this case. And we have a relative low amount of glucose in the tubular fluid in comparison to the amount of glucose within that simple cuboidal epithelium. So this, you're going to have high concentration of glucose versus lower concentration of glucose, okay? So now how does glucose go from in the tubular fluid that's lower concentration to a higher concentration within the simple cuboidal epithelial tissue of the proximal convoluted tubule? And that is through a sodium glucose symporter. So that's going to be sodium symporter. Now, how this works. You have a high concentration of sodium in the tubular fluid, okay? Inside the simple cuboidal epithelial tissue, we have a lower concentration of sodium. So sodium is going to be moving down its concentration gradient, going from tubular fluid into that cell, okay? So now how does this affect glucose? Well, it's a symporter. So as sodium moves down its concentration gradient, that kinetic energy, that movement of sodium, carries with it a glucose molecule. But, well, as the sodium goes from high concentration to low concentration, glucose is going from low concentration, tubular fluid, into the cell, which is a higher concentration of glucose. So that's the sodium glucose symporter. Sodium is moving from high concentration to low, and the kinetic energy is moving the glucose from the tubular fluid into that simple cuboidal epithelium where the concentration of glucose is higher. Now what do? The glucose then goes across the cell to the basolateral side. The basolateral, that's going to be this side because this is the luminal side down here, okay? So glucose is going towards the basolateral side where you have a glucose uniporter. So that's a glucose uniporter. Okay, so we have a high concentration gradient of glucose within the cell. We have a low concentration gradient of glucose within the capillary system. So glucose is going to diffuse down its concentration gradient and then enter into the bloodstream. Okay, so that's how glucose is completely reabsorbed. Now, if we were to look at protein, I don't have a decent picture for a protein. Basically, on the protein, what we're looking at is protein is not being reabsorbed as the protein itself. It's going to be transported. Okay, it's a little bit about nothing. Okay, so what we're looking at, protein that makes it into the tubular fluid is brought into the cell either through something like receptor-mediated endocytosis. It can be brought into the cell with like pinocytosis, okay? where you're taking large amounts of fluids in, which is like amino acids would come in with that as well. So that's what brings it into the cell. But it doesn't exit the cell to get to the bloodstream as that protein anymore. What the cell does is says it takes a lysosomes and it basically will degrade the protein down to its amino acid building blocks. So you have a protein in the tubular fluid, it is brought into the cell or transported into the cell where it is degraded to its building blocks of amino acids, and then the amino acids move into your bloodstream, and then those amino acids are recycled to do or to build other proteins. So they're used for something else. So glucose is reabsorbed as glucose. Proteins are transported into the simple cuboidal epithelium of the proximal convoluted tubule. They're degraded into the amino acid building blocks, and then those amino acids move into your bloodstream and they are utilized to build other types of proteins, whatever the body needs. So those are a couple of the substances that are completely reabsorbed. Now let's go through substances that are regulated as to how much is reabsorbed. So we're going to look at sodium and potassium and calcium and those different things, okay? All right, so before we go on into the next video, let me ask you a question, and you can put this answer on the discussion forum, so I want to see everybody responding. So here's your question. In a diabetic, give me a reason why they spill glucose over into the urine. So you have glucose being excreted into the urine. So that's your question. I want to see some answers by more than one or two people. So we'll go from there.